All right, welcome everybody to the Graphing Rational Functions Part 2 video. And in this video, we'll kind of talk about a special circumstance which brings in the wholes of an equation. Okay, so I had this part earlier in the videos, identify any problems. Well, we're going to have a situation where there is a problem in this particular problem. All right. So the first thing I need to do is I need to go through my steps, and as we work through these steps, we'll identify the problem that exists. Okay. So my first thing I always need to do is look to factor this thing or simplify the numerator and denominator. Now, what I'm going to do is I notice that I can factor out a number out of both of these. Now, in this case, I'm going to try to make my coefficient in front of x 1. Okay, so in order to do that, I'm going to factor out a -3, which makes that x, and that makes this -4. Now, make sure when I factor that if I distribute back out or I FOIL back out, that I get the exact same thing. So now also I'm going to factor this rather quickly. I need to find two factors of -8 that when added together equal -2, which in this case is x minus 4, x plus 2. Okay, so I've taken care of step numero uno, which is simplifying the function. Okay, my next step is I need to find the x-intercept. So in this case, I need to set the numerator equal to 0. So in this case, I'm going to take -3x minus 4 equals 0, and then I'm going to divide by -3, and so I'm left with x minus 4 equals 0, and then so I have x equals, sorry, my pen's running out there, x equals 4. And so I'm gonna hold off on that. I want to put this down here. The x-intercept exists at x equals 4, but I'm going to hold on to that because I'm going to show you where that's going to be a problem for us. So if I'm going to try to put like a little dot here just to make sure you guys understand. Just a little dot, okay? So I've noticed that the x-intercept is at 4. The problem is I can't erase this thing, or it erases the whole thing. All right, so I graphed the x-intercept, so that's done. All right, my next thing I need to do is I need to find the y-intercept. The y-intercept, in order to do that, all I got to do is plug 0 in for x. So if I do that, I have f of 0 equals -3 times 0, 0 minus 4 over 0 minus 4, 0 plus 2, and then we have equals -3 times -4, and -4 times 2. Hopefully we're getting these same results here, and so we get, let's see, 12 over -8, which simplifies to 3 over -2, or -3 halves. So my y-intercept is -1.5. All right. So that's going to go through right there. All right. I'm pretty sure that I'm not going to have any problems with my y-intercept, just because in order to be a function, we can only have one y-intercept based on the vertical line test, which you guys have familiarized yourself with. And so I'm starting to get kind of an idea of what this graph's going to look like. I got my x-intercept. I got the y-axis here. That's kind of crazy. It sees the answer underneath there. But what I need to do now is I'm going to continue with my steps, and I'm going to have the vertical asymptotes. So let's find vertical asymptotes by setting the denominator equal to 0. Now, because I've already factored this thing, I'm able to really just, basically, I've done all the hard work. Now I just have to say, all right, x equals 4 and x equals -2. So I have a vertical asymptote at -2, which I can see are no problems because I don't have any x-intercepts on that line. But when I do draw the 4, I see that although I did a subtle dot right there, it does go through my x-intercept, which I had earlier. This is a problem. Okay, this is the problem I was talking about here. This means that we have a hole to deal with, a hole. All right, now if we look up here, we can see why this hole exists, and that's because I can cross out the x minus 4 and x minus 4. All right. If I have this problem, I have to go through a process of plugging in the number 4 to actually see what it equals. Where does the hole exist? Now in this case, I'm going to plug 4 into my simplified answer, or my simplified function. In this case, it is -3 and x plus 2 on the bottom. I've crossed out the x minus 4s. So now I'm going to plug 4 into this function to see where this hole exists, and in this case it exists at -3/6 or negative 1/2. Okay, so my hole exists at 0 or 4 and 1/2. Negative 1/2, my mistake. So at negative 1/2, I'm going to have a hole that exists there. Okay, this is very important. We can't just generate another vertical asymptote because we are able to eliminate it, but still our function is undefined at 4, because if we plug it into our original function, we plug 4 in there, it's going to come out undefined. Okay, so what we need to do is compensate for that, but yet it does not mean that we have a vertical asymptote to deal with. Okay, so that deals with holes. That was the main thing I wanted to get across. Our next thing is find horizontal asymptotes. Now in this case, the degree of our numerator is less than our degree of our denominator. In that case, our horizontal asymptote exists at y equals 0. Alright, so we have a vertical or a horizontal asymptote at y equals 0, and then we're starting to really get a picture of what this thing's going to look like. And so for example, we know that it's going to go here, alright, because I found my y-axis and I found the hole that exists at that particular point. Let me do this in a different color. Let's do green. It's kind of hard to... So green, he's not going to go across the y-axis or the x-axis. He's just going to go right up against it, so my drawing looks that way. And just to be on the safe side, I am going to plug in a just negative 4 into the function. I'm actually going to plug it into my simplified function, which is perfectly fine. It makes life a little easier because I don't have to deal with a lot of stuff. So I'm just going to plug in negative 4 into my simplified function. Oh, let me fix this. Hopefully it didn't freeze up on me. Uh-oh, spray can. No, I don't want that. All right, there we go. So I'm going to plug it into my simplified function, which is negative 4 plus 2, which equals negative 4 is negative 3 over negative 2, which equals 3/2. All right, so negative 4 and 1.5. So that gives me a clear idea that my function is going to be up here, and I'm just going to draw a rough sketch of it, kind of get an idea of what it's going to look like. So that is my rational function. Now let me quickly go through, thank you for your time here. I just want to quickly go through just all the A's, B's, and C's and D's and stuff just to make sure you're all on the same page with that. And so that's going to be discontinued. It's discontinuous at negative 4, so x equals, or not negative 4, negative 2, and also at 4. Okay, those 2 points are where it's discontinuous. Like I said, it's kind of like a roller coaster. We're discontinuous. We have a problem when we get to negative 2, and we also have a problem at 4 because there's a hole in our track. All right, part B asks for the holes. Well, there's a hole at x equals 4. C, we could also write this as a point. We could say 4 negative 1/2 is where the hole actually exists. C, vertical asymptotes. We have vertical asymptote at x equals negative 2. D, we have, let's see, x-intercepts. Our x-intercept, none, because our horizontal asymptote is on the x-axis, so we have none x-intercepts. Part E, the horizontal asymptote is y equals 0. And part F, finally, the domain is all real numbers except x cannot equal negative 2 or negative or positive 4. Okay? Woo! You'll notice that there's a lot of overlap here. For example, discontinuous at these particular points. All right. Then you'll notice that it's also, the range includes all real numbers except where it is discontinuous. That's not necessarily a coincidence. That is why we say that we cannot plug in negative 2 or 4. So hopefully this video helped you. Please come in with your questions as you work through these problems. The best way to learn these things is to keep going and going through problems and fixing your mistakes. So thank you and have a good day.